This is the guided reading for weather forecasting in the 21st century. Do you notice that every few years new technologies develop? Digital music, GPS, and touchscreens are some examples of newer technologies. Finding new tools that improve how scientists predict weather is no exception. The science of predicting weather has come a long way. Joseph Henry, the first secretary of the Smithsonian Institution, tried to figure it out in the 1800s. See extending your knowledge, Joseph Henry, the father of weather forecasting. His passion led the United States to establish a national weather service. Then radar technology was applied to weather forecasting to locate storms. What will the 21st century bring? Radar is a trusted tool for a meteorologist, but upgrades to radars that make it better are possible, just like upgrading your cell phone for the newest features. A meteorologist wants to warn people about a looming storm as soon as possible, and newer radar technology helps them do so. One new feature is dual polarization or dual pol technology, which sends out horizontal and vertical waves. Not long ago, radar only transmitted horizontal pulses. Those pulses detected precipitation but couldn't tell the differences among rain, snow, or ice. Now the received data are two-dimensional, so we know exactly what is in the air. Another feature of the dual pol technology is that it detects tornado debris in the air. This is important because forecasters can warn people about ongoing tornadoes even when they happen in the dark. The NOAA completed an upgrade on 151 operating Doppler radars in 2013. We have a photo here that shows the map of the Doppler radar, what's going to show up. And then over here, a phased array radar dome may advance the science of weather prediction. Another active radar project is testing its multifunction phased array radar, or MPAR. The United States Navy has used technology to track enemy ships and missiles. This type of radar may also be helpful for weather forecasting. Current Doppler radar has a few limitations. A Doppler radar dish must be tilted mechanically to scan sections of the atmosphere one at a time. It scans from the lowest to the highest elevation and starts the cycle again. A phase array radar has electronic steering. The capability gives users more control of scanning. It also has an antenna that transmits several pulses at the same time. As a result, scanning time is shorter. According to the NOAA, the National Severe Storms Laboratory, MPAR can scan the sky in less than 1 minute. Forecasters think that this radar could extend warning times for several weather events such as tornadoes and flash floods. Updates could be more frequent. Changes to forecasting in the 21st century are also happening off the ground. In 2005, aircraft that had previously only been for military use started engineering the realm of weather forecasting. Unmanned air vehicles, or UAVs, are proving helpful in hurricane tracking and data collection in the atmosphere. The 2005 hurricane season is primarily remembered for several storms that hit states bordering the Gulf of Mexico, including Cindy, Rita, and most notably Katrina. Hurricane monitoring by manned aircraft had been common at the time, but that method has had a few drawbacks. The first issue is the risk for people flying in bad conditions. Another issue is that pilots can only stay in the air a limited amount of time. Later that year marked the first time a UAV flew into the tropical storm. The storm system named Ophelia switched between hurricane and tropical storm status. It was a tropical storm when the UAV flew through it. So over here on the left, you can see the MPA multiple scan of a tornadic storm. And then an unmanned air vehicle that can be used for weather forecasting to gather data and other information. Introducing the UAV weather forecasting has several benefits. First, it is much safer for people. Second, it constantly monitors the conditions in the atmosphere during storms. Also, salt spray is bad for some parts of piloted planes, so they cannot fly as low. The UAV that explored Ophelia could fly at 500 feet above water. That was much lower than any pilot that could fly. The low height let the aircraft observe the interaction between the water and the storm from closer than ever before. In later years, UAVs have flown at even lower altitudes in full hurricane force sustained winds. The UAVs can also obtain imagery and data from the storm that satellites cannot, because UAVs can get closer. In the months and years to come, technology will keep advancing. As it happens, we are sure to see more changes in weather forecasting. It is only the beginning of the 21st century. Imagine what the future holds.